Hello, my name is Jason Johnson, and thank you for watching. I hope you find my videos helpful, and thank you for subscribing and sharing them with others. If you have a question or feedback, you can leave a comment below, and I'll get back with you as soon as possible. This video is going to be over the Cisco Netacad IT Essentials, Chapter 8, Applied Networking. And we are going to cover a few different things in this video. We're going to be looking at computer to network connection, ISP technologies, internet technologies, common maintenance techniques, and basic troubleshooting process. And I was going to break this video into two parts, but I decided to just keep it into one part, and it's going to be a run about, I'm hoping to keep it under 20 minutes. But instead of breaking it into two, one was going to be like 12 minutes, 15 minutes, and the other was going to be a short one, the 8.4, 8.5. So I just decided to go ahead and make it one long video. So let's take a look here at computer to network connection. Now, when you put a computer on a network, when you want to do some type of communication between one device and another, you have to have a network interface card, or in what we call in the industry a NIC card. And it's just pronounced NIC, N-I-C, NIC card. And if you're in the technology field and somebody says, I need a NIC card, that's what they're talking about, is a network interface card. Now, regardless of whether you're using a plug-in network card, where you would plug in an RJ45 connection here, and that would be cabled and you're using Ethernet, or if you're using wireless, they both work on the same principle. One just transmits through copper wire, and one transmits through wireless, either through radio frequency or maybe even Bluetooth if you're using a Bluetooth connection, or some type of wireless. So when you plug in this one here, this one's usually in a desktop. This is what you're going to most commonly see in the industry. You're going to see a card that plugs in on your motherboard. This is open on the back, and you would plug in your connection there. You have your activity lights here that let you know that it's connected and that you're getting activity. This wireless card here, this is your antenna that comes up on there, and you're not going to see those as often, and then you're not going to see these as often, but there are occasions where you do use them. If you have a computer that you cannot get a wire to easily, or it's just, it's not a good location, or the wire's getting a lot of interference, you can put a wireless network card in, and then you can then locate that computer somewhere where you don't have to run cable to it. Now, it's not going to be as fast a connection in some cases, and you may have interference, and there's a number of other issues, but it does solve some problems of not having to run a wire to that device. And then when you're talking about laptops and mobile devices, those have the wireless built into those, and those antenna, you don't see those, but those are built into the case or built into the side of the chassis of a laptop or into a case of a mobile device. Now, when we install those network cards, we have to then connect to the network. And after we install that network card, we have to set our IP settings, or our Internet Protocol settings, and those can be configured either manually or dynamically. Now, if you configure those manually, and this is a Windows screen here, you would go in manually and you would set that whether it's a V4 address, and would set a IPv4 address here, and you can set that. You would select that radio button, and you would put your IP address in, your subnet mask, your default gateway. And if you want more help on subnetting and help on that, look in the description below. I've got links to my subnetting made easy videos. It's like other people's, but it's something that I've put together. And you would set those manually, and you would set your DNS server manually. But in most cases, and what's ideal is that we use an automatic addressing scheme, or an automatic the computing device gets on the network and it sends an ARP request, ARP, and it sends that ARP request and it says, hey, I need an IP address. And then there is a DHCP server, DHCP, and we've talked about that in a previous video, what DHCP is. And DHCP server says, yes, I've got IP addresses here, you can have one. And so that gets automatically assigned. You don't see it right here. It doesn't show up there. You have to go into a command line, or you have to go into the advanced settings to be able to see the IP address. But you can also set things such as speed, duplex, wake on LAN, and quality of service, or QoS, on that network card. You can also configure that in the advanced settings. Now, when we are connecting, regardless of whether it's wired or wireless, there's settings that you have to make to connect a network attached to an Ethernet. You would Ethernet. There's an Ethernet connection there with an RJ45. You'd plug that in. It's got a wireless radio there and the wireless antenna there, and that you would plug that into the back. This is I can't tell what that's, a Cisco home router. with 4 ports right there, 1, 2, 3, 4, and this is the that's the WAN side right there that they're plugging into. So they'd plug your network into that, and then you would plug your devices into there, or they would connect through wirelessly. So one end connects to your either your modem, or your ISP modem, or your router, and that's coming to your ISP, and then it's going to then connect to either your wireless connecting router. That's going to connect either to an ISP, or you're going to have an internal router that connects to or connects to your modem to your ISP, and that information is going to flow through, and then it's going to go either through the antennas or through one of those 4 ports there. So the wireless connections, you configure the router with the following. You can go into the web browser, you set up the router, and in this case it's 10.10.10.1. You go into the settings here, and you can tell it what network mode you're going to do in. This is a wireless in, whether you're going to do AC, which is the newer standard, or in, or even set up one of the older ones, which in. This is videos being made in April of 2017. I don't know why you would do anything earlier than in, unless you had some older specific wireless devices that ran on an earlier version other than in, and you just have to have that network set up for that. So you would go in and you would set up your what mode you're going to do, your network name, your SSID, which is broadcast. That is what broadcast out to wireless networks. Now, some will tell you on a secure part of the security to set up is you do not broadcast an SSID. I don't broadcast my personal one at my house. I leave it blank, but I have to go and type it in every time. And then I've got a visitor one or a guest one that's visible to everybody else, so that if I have people come over to the house and they need internet, I give them that one. But just somebody pulling up to my house will not be able to see that ID. However, they can still scan for it and find it. It's just not easily available. And then you're going to set your channels, and you're going to set, whether your broadcast is being sent or not, that information there. And the channel is important when you're setting there, because you could have multiple wireless access points, and that's what an AP is. You'll either see WAP for wireless access point or AP for access point, and you may have multiples of those in a building. So I'm just going to draw right here. Let's say we have a building here, and I have an antenna here, and I've got wireless here, and then I've got another one over here that somebody has put up, maybe in the apartment, and there's 2 apartments here, and then we've got apartment A and we've got apartment B. And they've put their wireless tower real close to yours, and theirs is broadcasting on a channel that is interfering with yours. Maybe they pick channel 2 and you pick channel 2. They're going to interfere with each other. They're going to cancel each other out, or you're going to get interference. So what you have to do is then change your channel to another number so that it doesn't do that. And then you're going to set up your wireless security on there. So when you're doing network sharing, okay, so you've went in, you've made your main setup here, and you've got your network running, but then you want to set up network sharing. Network sharing is where you can share resources between devices, or between two computers. And so Windows computers on a network must be either part of a domain or a work group. If you just get onto a computer and you're broadcasting, sometimes, and this is in general, sometimes you can still get in and see computers. You can port in, or they've got open ports on a computer. That's not what I'm talking about. I'm talking about just regular network. If you just go in and look at the network settings, you're going to either need to be on a domain or a work group to be able to see resources. So before they can share, you set a common work group that different computers are in, or you put that computer onto a domain. A domain service that's being run by a Windows server. You can also map a local drive. That's a way to access a file repeatedly. So every time you boot up, you can say, I want to map a local drive. So, for example, you could map the drive letter K, and you could say, every time I log onto this computer, I want K to point to a network resource somewhere. You can also determine which resources will be shared over the network. You can set whether it's either read or change or full control. You just want to be careful about giving different access for different folders for different permissions. You don't want to give full control to everything on your computer on those work group computers, because if you get a rogue computer put into that network and you don't have proper security set up, someone could come in and see your resources and change files and do different things to it. So you just want to be careful about that security on there. Now, when we do remote connections, and this is where you want to get into being careful about connecting in, but a remote is what we call a virtual private network, or a VPN. I would say if you're going to be doing any traveling, or if you're going to be doing on any network that you're not familiar with, you want to use a VPN. And that is a private network that connects to a remote site or users together over a public network like the internet. But what you do with the VPN is you can use a corporate private network. Companies will set up VPNs so that employees can connect to them. And what that is it's basically setting up a portal between two devices on the internet. So it's encrypting that information between those 2 points. So you have a VPN point, and you go to your VPN and you get on your local internet connection. Let's say that you stop, you're at a hotel, and you're going to get on your local internet connection, and then you're using their router, their service, and at that point, they can see all of your data that's going through. In some cases, even if it's encrypted, sometimes they can still they're still seeing your traffic that's going through, and it could be decrypted, or if things are going through, you're just never sure. So what you want to do is you connect into a VPN. The VPN sets up a connection where it's encrypted from point to point, and then it's a lot harder to get that information. So it's basically the same as if two computers were on the same LAN together. You can share resources just like they were on the same physical LAN together, but you're actually going across the internet. Now, remote access users must install the VPN client if you're using a VPN client or the remote desktop connection with Windows. Remote desktop allows technicians also to view and control a computer from a remote location. So you want to be careful with those services and who you're allowing to remote into yours. Remote assistance allows technicians to assist customers with problems from a remote location. I think I just said that. I think it's saying this twice here. I think this is typed in twice on the PowerPoint here, so that's interesting. I may cut this out of the video. We're going to cut this out of the video here. So we're going to go back now. Okay, so next we want to look at ISP connection technologies. Some of the technologies that we work with, whether you might have a DSL, or you might have a cellular, you might have line of sight, you might have cable, you might have satellite or fiber broadband. It just depends on which area you are in and which service is being provided by some type of company. It can range anywhere from a company like Comcast, Comcast or CenturyLink, a large, and where I'm talking about in the United States, or you can talk about some cities will offer services. The city I live in, the local power company also offers a internet service through the power company. But you can either have a DSL line, which is the old copper lines that come in, but they still use DSL on that. They use the telephone companies are still using those. Line of sight wireless internet, you can set up an antenna on your house and point it to a tower somewhere. Cell technology, you can use just like your cell phone, just 4G or 3G or the newer 4G that's coming through. But you can do transfer of video, voice, and data. Cell technology is not as advanced as far as speed, and it's expensive, but it does help for sometimes when you're out somewhere and you need internet. Cable is by far the most common in the United States. That's where you put coax cable lines in. You also get your cable TV, or you can also get your telephone through that. That's what's commonly used. And then you also have satellite. Those are the customers that cannot get cable or DSL connections. Those are farther out and away from ISPs. And so you have to do you point a satellite up at and it's usually not this large. I had one a few years back when I lived out in the country, and it was probably I would say maybe 2 or 3 foot across. It wasn't, and also the bandwidth is limited, especially the upload speeds are limited. And then so what I was doing was I was doing my download through the satellite, my upload through my DSL line, and tying it through that way so I could get a little bit better speed on it. But it was still it was painful as far as I couldn't do any type of video and things like that. It was mainly sending email and some things like that. Fiber optic by far is the fastest. That is what's being put in a lot of cities, but fiber is coming in, and it's using light or fiber optics, and that's getting faster speeds than any cable or DSL or any of the other technologies. Now, once you get your ISP set up, we look at internet technologies. And when we look back at the data center, so we've got our local network set up or local network set up, then you connect your ISP. And then the ISP has these data centers, or they connect into the data centers. I mean, you might have an Amazon or a Facebook or a Google, or even Cisco, and they have these large data centers or these large computing places that offer services. So a data center, the term data center, they offer housing for your data. You can run your in-house in-house data with an IT department, but if you're a company that cannot afford an IT department or you can't afford the big servers, you would hire that done on the cloud computing. And it's an off-premise service that provides on-demand access to shared pool of computing resources. So you might have a web server set up, but you don't have to do that on location. So if you store it, if you do it in-house or you do it on your location or inside your company, it's called in-house or local. And if you do it out with somebody, outsource it with somebody else, it's cloud computing. And the three main cloud services, and you need to know these, the three main cloud service models are SaaS, PaaS, and IaaS. And that's software as a service. The way I pronounce it is SaaS, PaaS, and IaaS. It's infrastructure as a service, platform as a service, or software as a service. And a example of software as a service is, let's say that you set up an email service through Google or Outlook through Microsoft, and you set that service up on the internet for your employees to use email. That's a software that's hosted in the cloud. A platform would be where you would set up your file server, or you'd set your servers up on the internet, and then you would have your platform there. And then your infrastructure is where you would actually have your hardware, or that you would use someone's hardware to set up, and you could set up virtual machines and things like that in the cloud. Now, the four cloud deployment models are private, public, community, and hybrid. And private just means you're going to have private where only you or your company has access to it. Public is going to be obviously public, and those are going to be things where you can have anybody come in and see those. A community would maybe where you have a city or a company that's allowing anybody from a certain community or group that comes into that. And then hybrid could be a combination of those when we're talking about deployment models. Now, when we talk about network hosting services, when you hosts need a variety of services to securely access resources on the network and the internet, and some of those services that you want to be familiar with. And the first one is DHCP, or Dynamic Host Configuration Protocol, and that's what I mentioned earlier. That receives your IP address, or your NIC card receives your IP address from some point, and that's your DHCP server. Domain Name Service, DNS. That is what allows IP addresses to be converted to a name or domain name service. So, for example, if you were going to go to Cisco.com, you don't have to go find the IP address. You can just type in Cisco.com, and the DNS server, the domain name service or DNS converts that for you. HTTP and HTTPS is your website. TTP serves your regular web pages, and HTTPS is your encrypted part of that. So if you're going to do banking, you want to make sure that you're on HTTPS. File transfer protocol. That's where you're transferring files. You have FTPS, which is File Transfer Protocol Secure. It encrypts the connection. And then you have SSH, File Transfer Protocol, or SFTP, and then Secure Copy. And on your mail side, you've got SMTP, and we talked about these in another video. I'm just recapping those. But you've got SMTP, which is your Simple Mail Transfer Protocol, and Post Office Protocol. And remember, SMTP leaves your messages on the server until you delete them, so you can retrieve those from any location. And POP, the Post Office Protocol, downloads the messages once you retrieve those. So once a client downloads those get removed off the server. And then IMAP as well. So IMAP is the protocol host used to send and receive mail. IMAP is what sends and receive. Okay, so we're also going to look at print servers. You have a print server set up, multiple computers access a single printer. You can set that up so you don't have to buy a printer for everyone's desk. You can just buy one larger copy or a printer, copy/printer, and then you can have everybody in your organization print to that location. Proxy servers are popular because they used as storage or cache for web pages that are frequently accessed on the host on the internal network. So a proxy server sets up and says, okay, so we know our users are going to this particular web page a lot, so a proxy server will cache or save copies of that web page. So if there's certain images on that web page that get downloaded a lot, well, instead of downloading those every time that somebody goes to that web page, for example, with the Netacad website, if you were going to go into the Netacad website, well, the Netacad logos that's set up the top, you don't want to have to download those every time. So those just get cached onto the local server, and those get served from the local server instead of having to go out to the internet. Now, AAA or AAA is a way to control who's permitted to access a network or authentication. And so it authenticates what they can do while they're there, which is authorized, and then also the accounting part of it. And then IDSs, there is an IDS, which is an intrusion detection system, and then there's an intrusion prevention system. And now those are two different things. IDSs and IPSs are two different things. And don't get IPS confused with ISP. An intrusion detection system passively monitors traffic on a network, while intrusion prevention can detect and immediately address a network problem. And so those are two different things, and they work differently. One is intrusion detection, just sits back and passively monitors traffic. It's not as immediate. It doesn't work. It doesn't react as fast. And then intrusion prevention systems can detect and immediately address network problems. That's, for example, if someone's doing a denial of service on your network, those can the IPS would take care of that faster. And then you have Universal Threat Management, or UTM. That includes the functionality of the IDS, IPS, as well as your stateful firewall services. So that's called your UTM, or Universal Threat Management. Now let's look at a common preventative maintenance techniques used for networks. And we are going over 20 minutes on the video, so I apologize for that, but we're just going to get these last two pieces in here. And so you're already familiar with the preventative steps and the different steps that you take for preventative maintenance. But on a network, just like hardware, you have to do certain things to maintain it. So preventative maintenance for networks include the condition of the cables. You don't want to run cables in an outdoor environment unless they're protected. You don't want to have cables being run over by a chair or have footwear traffic step on those, because those are going to degrade over time. So you want to make sure that you are looking at your cables, your network devices, the computers, to make sure that they're kept clean and that they're in good working order. You should develop a plan to perform a scheduled maintenance and cleaning at regular intervals. And then also you want to inform the network administrator if you notice any of those issues that prevent unnecessary network downtime. So if there's things that that a cable's running across maybe sticking out somewhere and getting footwear traffic across it, or something's rubbing against it, and it's going to have problems, then you want to notify your network administrator. Now, basic troubleshooting processes, just like what we've already learned in previous videos, you want to identify the problem. You want to establish a theory of probable cause. You want to test the theory to determine the cause. And then you want to establish a plan of action to resolve the problem and to implement the solution. So we've already learned these. So identify the problem, establish a theory, test the theory, establish a plan of action, and then we are going to verify full network functionality, or verify functionality, implement preventative measures, and then document everything, so that you know what happened, so you can prevent it from happening in the future. Now, network problems can be attributed to hardware, software, or configuration issues. That's why I like working in networks, because it's always kind of a puzzle to figure out where the issues are. It could be software, it could be hardware, could be configuration issues. So it's just, you want to use those troubleshooting steps so that you can find the right solution. Now, common networking problems also include network cables are damaged or unplugged. Always check the simple things first. Early on in my career, I had a computer, could not get on the network, and this was back in the late 90s. And so I was configuring everything. I installed new drivers, and finally I moved around to the back of the computer and the network cable was unplugged. So I probably spent about 15-20 minutes installing software and doing different things, and the network cable was unplugged. So always check the simple things first. Legitimate users are denied remote access. That's a network problem where someone can't get logged in. The device lacks sufficient addressing information. Users cannot access the internet, or a user cannot map a drive. Those are some of the common things. Now, that doesn't encompass everything, but that's some of the common things. Okay, so this has been Chapter 8, and we have taken a look at a lot of different topics here. I'm at the 25-minute mark on this video, so I'm not going to go down through each one of these. If you want to look at the conclusion page here, just go ahead and pause your video. I'm going to go ahead and conclude here. Thank you for watching this video. Thank you for sharing it. Thank you for subscribing to my channel, and I hope you have a great day.